हेलो।
हाँ जी सर। हेलो।
हेलो हेलो। चेक चेक चेक। चेक 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 चेक।
This conference is being recorded.
Good afternoon, everyone. I request the audience sitting at the back to kindly take seats in the front. Please fill up the seats in front. I request the audience sitting at the back, please fill up the seats in the front. Please occupy the front rows. I request everyone to settle down, please. Good afternoon, everyone. अभी ठीक है?
Hello, 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 hello. Hello, hello. Hello, check this. 1, 2.
Good afternoon, ladies and gentlemen. I am Dr. Vanda Prajapati, Scientist D in the Department of Biotechnology. And I request you to please be seated and switch off your mobile phones. The program shall start with the arrival of the chief guest, Dr. Jitendra Singh Ji, Honorable Union Minister of State, Independent Charge, Ministry of Science and Technology. Till then, let me take you briefly through the events of today's program. The program has been structured into 2 sessions, wherein the first session shall be graced by the chief guest, Dr. Jitendra Singh Ji, Honorable Union Minister of State, Independent Charge, Ministry of Science and Technology. This session shall entail addresses by the chief guest, guest of honor, Secretary DBT, Additional Secretary and Financial Advisor DBT, and the Joint Secretary DBT. The second session comprises of the Foundation Day lecture, followed by pitch talks by 5 young researchers on the futuristic areas of biotechnology. I would request you to please settle down. Thank you. Ladies and gentlemen, our chief guest, Dr. Jitendra Singh Ji, Honorable Union Minister of State, will be arriving shortly. Ladies and gentlemen, our chief guest, Dr. Jitendra Singh Ji, Honorable Union Minister of State, Independent Charge, Ministry of Science and Technology, has arrived. Let's give a resounding applause as he joins us.
Mukharia.
He's there. He's there. He's there. Honorable Union Minister of State, Independent Charge, Ministry of Science and Technology, Government of India, Dr. Jitendra Singh Ji, Dr. Govind K. Makharia, Professor, AIMS Delhi, Dr. Rajesh S. Gokhale, Secretary, Department of Biotechnology, Ministry of Science and Technology, Government of India, Director General, BRIC, and Chairman, BIRAC. Srimati Yatinder Prasad, Additional Secretary and Financial Advisor, DBT, and Ms. Ekta Vishnoi, Joint Secretary, DBT, Ministry of Science and Technology, Government of India, colleagues from DBT, press and media, and esteemed ladies and gentlemen. A very warm welcome and greetings to each and every one of you. On behalf of the Department of Biotechnology, I welcome you all in the 40th Foundation Day celebrations of the Department of Biotechnology. Light symbolizes knowledge, prosperity, and a new beginning. To seek blessings of the divine, may I now invite the dignitaries on the dais, our chief guest, Honorable Union Minister of State, Dr. Jitendra Singh Ji, guest of honor, Dr. Govind K. Makharia, AIMS Delhi, Dr. Rajesh S. Gokhale, Secretary DBT, Srimati Yatinder Prasad, AS and FA DBT, and Ms. Ekta Vishnoi, Joint Secretary DBT, to lighten the lamp of knowledge and wisdom. As our esteemed guest, lighten this lamp, I request everyone to kindly stand at your places, please, for Saraswati Vandana. Please stand at your places. Let's immerse ourselves into the beautiful transition from darkness to light and experience the divine presence of Goddess Saraswati. May this light continue to guide us. Thank you. May I now request Dr. Rajesh S. Gokhale, Secretary DBT, to felicitate Dr. Jitendra Singh Ji, Honorable Union Minister of State, Government of India, with a memento and a shawl as a welcome token. Thank you, sir. I also request Dr. Gokhale to felicitate Dr. Makharia. Thank you, sir. May I now request Ms. Ekta Vishnoi, Joint Secretary DBT, to felicitate and welcome Dr. Rajesh S. Gokhale, Secretary DBT. Thank you, ma'am. I once again request JS Madam. To felicitate Srimati Yatinder Prasad, Additional Secretary and Financial Advisor, DBT. Thank you, ma'am. Ladies and gentlemen, it was the decade of 1980s when several technological breakthroughs happened. It was the era when FDA approved Humulin, the world's first ever recombinant DNA medication, and the first automated DNA sequencer was developed. Here for us in India, Wing Commander Mr. Rakesh Sharma declared our nation Sare Jahan Se Acha from space. The country also witnessed the arrival of the first Maruti 800s, and the first soap opera, Hum Log, became the talk of every household. And in the same decade, a toddler who has grown up to become a part of this esteemed organization was also born. At that very moment, on 26th February 1986, a separate Department of Biotechnology under the Ministry of Science and Technology was being formed with a cherished dream of advancing the country in science and technology. The organization that was born as a tiny seed of an idea is now turning into a 40-year-old fruit-bearing tree and has brought us together under one roof to celebrate its 40th year of establishment. On this momentous occasion, I would like to invite Ms. Ekta Vishnoi, Joint Secretary DBT, to kindly deliver the welcome address, please. Ma'am.
Good afternoon, everyone. On behalf of the Department of Biotechnology, Ministry of Science and Technology, Government of India, it's my privilege and honor to welcome our chief guest, Dr. Jitendra Singh Ji, Honorable Union Minister of State, Independent Charge, Ministry of Science and Technology, and Ministry of Earth Sciences, Minister of State in the Prime Minister's Office, Ministry of Personal, Public Grievances and Pensions, Department of Atomic Energy, and Department of Space. I also extend a heartfelt welcome to our guest of honor, Professor Govind K. Makharia from All India Institute of Medical Sciences, New Delhi, Dr. Rajesh S. Gokhale, Secretary DBT, DG BRIC, and Chairman BIRAC, Srimati Yatinder Prasad, Additional Secretary and Financial Advisor, DBT, distinguished dignitaries, present and former DBT officials, colleagues from BIRAC, members of DBT, BRIC institutions, friends from the media, and ladies and gentlemen who have joined us today to celebrate this 40th Foundation Day of Department of Biotechnology. Today is not just a ceremony. It's a celebration of a journey of institution building. The National Institute of Technology, NII, the first institute under DBT, it was more than a beginning. It was a statement of intent. That intent grew into a powerful ecosystem. Today, represented by BRIC, Biotechnology Research and Innovation Council, the apex body of DBT, bringing together 13 premier institutions along with ICGB and RCB. Together, they contribute not just to research, but to sustainable development goals, to national missions, and to India's global scientific leadership. Then came another transformative step, BIRAC. And BIRAC did something extraordinary. It connected science with the enterprise. It gave our innovators confidence to dream. It helped ideas to move from the lab to the marketplace. And because of this ecosystem, which the department has built over 40 years, India stands today as the largest vaccine manufacturers in the world. Yes, the numbers do tell a powerful story. From a $10 billion bioeconomy in 2014 to $165.7 billion in 2024, 12th globally in biotechnology, 3rd in Asia Pacific region, 3rd largest startup ecosystem in the world. These achievements tell the story of a teamwork, of scientists who worked late into the night, of administrators who ensured systems moved seamlessly, of financial teams who enabled scale, leaders who saw possibilities even before they were visible. Past and present leadership, working together, they have shaped this department into what it is today. Every discovery carries the imprint of collective effort. Every achievement carries the spirit of collaboration. Today, DBT enters its next phase, driving high-performance biomanufacturing through the Bio-E3 policy, integrating economy, environment, and employment. This is biotechnology, not only for growth, but for sustainability, not only for innovation, but for the national transformation. DBT remains committed for nurturing a vibrant research and innovation ecosystem aligned with Honorable Prime Minister's vision of Viksit Bharat at 2047. Under the visionary leadership and constant guidance of Honorable Minister Dr. Jitendra Singh Ji, the department has accelerated innovation, strengthened its mission, and elevated India's position as a global biotechnology leader. Sir, your encouragement has empowered this ecosystem to think bigger, move faster, and aim higher. As we celebrate 40 years, we do so with pride, but also with purpose. Because next 40 years will demand even greater courage, even deeper collaboration, and even bolder science. The 40th Foundation Day of DBT, it's not just a milestone in time. It's a reaffirmation of our commitment to science, to society, to a stronger, resilient, Atmanirbhar and Viksit Bharat. With that spirit and with immense pride, I once again welcome you all to this 40th Foundation Day celebrations of Department of Biotechnology. Thank you. Jai Hind.
Thank you, Madam. I now invite Dr. Makharia to kindly deliver the special address on this auspicious occasion. Dr. Govind K. Makharia is professor in the Department of Gastroenterology and Human Nutrition at the All India Institute of Medical Sciences, New Delhi. He holds key leadership positions in various international and national bodies, including World Gastroenterology Organization, Asia Pacific Colorectal Cancer Study Group, Asian Pacific Committee on Celiac Disease, Governing Council of the Indian Council of Medical Research, Government of India. He has been instrumental in developing several global, Asian, and Indian clinicians' practice guidelines on various gastrointestinal diseases. Dr. Makharia's research in celiac disease has fundamentally reshaped the understanding of intestinal health. He is recipient of several awards and is fellow of INSA and National Academy of Medical Sciences. Please join me in welcoming Dr. Makharia to the floor.
Thank you so very much, and very good afternoon, everyone. Dr. Singh, our Minister, Dr. Gokhale, Secretary DBT, Ekta ji, Itundar ji, the senior leadership of DBT, both past and present, and scientists, leaders of various institutions, and dear friends. I think this is a momentous occasion of foundation of an institution which is one of the important institutions who builds India. The science and technology, which is a part of any country, which is so important. Any country rises because of innovation, science and technology. And this is one department which is playing a very important role and likely to play a role in the future too. So I have a few messages on this Foundation Day. Number one, that any scientist or any innovation, be it in diagnostic, understanding pathophysiology, understanding, making new diagnostic therapy or making new therapies, have a long setting. It requires a dedication of a person or a group of people, a team which works together, and ultimately the daytime working and nighttime dreaming. You think about it and plan your pathways, and that leads to an innovation. This innovation can turn lives of millions around the world. So therefore, it's so important for each one of us as a scientist to think what I'm doing, is it a right question? And the answer, we're going to change the life of many of us. Therefore, working together is a second, my theme was this, working together as a collaboration. Because any big thing come with collaboration of people with different abilities, the institutions with different capacities work together. And of that, Chandrayaan is one example. We all know that day when it landed on the moon. I think all our eyes were wet that day, am I right? And our throats were choked with pride and honor. That's what innovation is. And that's how did it come? It comes with a high quality collaboration between hundreds of scientists and hundreds of institutions together. That leads to innovation. So collaboration is the key for scientific research. At this point of time, we have hundreds of class institutions in our country, thousands of scientists. But each one of us make some knowledge, small studies, which gives you small knowledge, but does not make a whole garland of information to make a transformation. So our work, which is very relevant, very, very relevant, but working together, each piece should connect with each other, will give to us a scientific knowledge which is useful. And therefore, that becomes an important task for each of us, to think in that way, that we collaborate and think not only of a small question, but think of working together in a right question and in a coherence manner, so that our research becomes more useful. My third point to myself and to all of you is that India has to develop in science technology. And for that, we have a limited budget. This budget, part of the budget must be invested into a thing which is a mission mode. We want to make vaccine, like we made COVID vaccine. So some amount of our scientific budget must go into a very coordinated top-down approach so that those discoveries are useful to us. And my last point to young scientists, that it's a great future for Indian science. Enjoy it and gain from it. With that, I'd like to congratulate all of you on your Foundation Day. Thank you so very much.
Thank you, sir. Ladies and gentlemen, DBT started its journey as a National Biotechnology Board in 1984 to becoming a fully fledged department in 1986. Department, since its infancy, has been nurtured by scientific luminaries Dr. S. Ramachandran, Dr. C.R. Bhatia, Dr. Manju Sharma, Dr. M.K. Bhan, Dr. Vijay K. Raghavan, Dr. Renu Swarup, and Dr. Rajesh S. Gokhale, and was ably supported by scientific officers, finance, and administrators in its ventures into new arenas, whether it's the establishment of BIRAC or DBT Wellcome Trust Alliance or BRIC institutions, which are instruments of first of its kind in the Government of India. DBT Media Cell has compressed this DBT's journey of 14,600 days in a short film of 5 minutes. Let's together witness this journey of DBT from the era of physical files to the age of e-files and AI. May I request to roll the film, please?
इक्कीसवीं सदी में बायोटेक्नोलॉजी और बायोमास का कॉम्बिनेशन बायो इकोनॉमी के रूप में विकसित भारत की बुनियाद का अहम हिस्सा है।
1986 marked a defining moment in India's scientific journey. The Government of India established the Department of Biotechnology, placing life sciences at the heart of national development. From its very inception, the mission of DBT was clear: to build cutting-edge scientific research and ensure that the benefits of biotechnology reached society at large. By investing in institutions, infrastructure, and human capital, DBT created a seamless pathway from laboratories to real-world impact. The first wave of institution building began with the National Institute of Immunology, followed by NCCAs, ICGB, NBRC, CDFD, and NIPGR. To support this growing ecosystem, DBT launched Biotechnology Information System Network, BTISNet, laying the digital foundation for life sciences research in India. On the other hand, as early as 1985, PG programs on biotech were started in 6 universities. Currently, 71 universities being supported. India was not just consuming knowledge, it was generating it. These foundations translated into impact. Breakthroughs included HIV by DOT and Thri-DOT test kits, and the birth of Pratham, the world's first IVF buffalo calf, demonstrating biotechnology's power in health and rural development. In 1989, DBT established the Review Committee on Genetic Manipulation, RCGM, ensuring safe and ethical biotechnology development. Entering the 2000s, a second wave of institution building strengthened India's scientific footprint with NIBMG, RGCB, THSTI, NIAB, NABI, in STEM, RCB, and IBSD. In 2012, Biotechnology Industry Research Assistance Council, BIRAC, was established to bridge science and industry, nurturing biotech enterprises and accelerating innovation. From 2014 onwards, biotechnology entered an era of acceleration. Under the visionary leadership of Honorable Prime Minister Shri Narendra Modi ji, biotechnology became a pillar of economic growth and self-reliance. DBT and BIRAC support enabled indigenous vaccines during the COVID-19 pandemic and emerged as the world's largest vaccine producer. Over 3 lakh COVID-19 samples were sequenced, strengthening genomic surveillance. Rotavac received WHO pre-qualification, and Servavac became India's first indigenously developed quadrivalent HPV vaccine, expanding preventive healthcare access. BIRAC is supporting entrepreneurship, innovation, incubation, and fostering mentorship, ensuring discoveries reach markets and communities. Through the National Biopharma Mission, industry-academia collaboration accelerated vaccines, biosimilars, medical devices, and diagnostics. The bioeconomy transformed into a major engine of growth and sustainability. The biotech startup ecosystem expanded to over 11,000 startups in 2025. For strengthening ease doing research, we have created BRIC. Biotechnology is now making a paradigm shift towards regenerative principles by scaling biology via high-performance biomanufacturing.
And just as the industrial revolution of 1990s was IT-driven, the next revolution of the 21st century is going to be bio-driven.
To realize this vision, the Union Cabinet approved the Integrated BioE3 policy, biotechnology for economy, environment and employment, aligning science with national priorities of accelerated green growth.
बायो 3 पॉलिसी भारत सरकार ने बनाई है। मैं देश के नौजवानों को कहता हूं, आइए बायो 3 पॉलिसी का अध्ययन करके अब कदम उठाइए। देश का भाग्य बदलना है, आपका सहयोग चाहिए।
Echoing this vision, Honorable Minister Dr. Jitendra Singh launched the Design for BioE3 Challenge. We established National Agri-Food and Biomanufacturing Institute, supported 6 National Biofoundry Network and 21 Bio-Enablers to accelerate scale and self-reliance in biomanufacturing. DBT, in collaboration with ISRO, expanded into space as Group Captain Shubhanshu Shukla flew aboard Axiom Mission 4, advancing space biology research. In National Genomic Data Exchange Framework, made 10,000 whole genome sequences globally accessible. Further, 20,000 TB genomes sequenced to strengthen precision diagnosis. India advanced therapeutic innovation, including lentiviral gene therapy and the scientific completion of its first indigenous antibiotic, nafithromycin. In agriculture, biotechnology is driving climate-resilient crop development. Speed breeding facilities at Varanasi, Mohali, and Ludhiana are accelerating next-generation varieties. Innovations such as Kisan Kavach strengthen farmer safety. In the realm of clean energy and environment, we remain committed to a sustainable future. The I3C BRIC PhD program is enabling research translation. Biotechnology is no longer confined to laboratories. It is a national movement driven by the aspirations of young India. As biology scales from discovery to deployment, DBT, BIRAC, and BRIC collectively drive India's bio-revolution, translating science into societal and economic transformation. As DBT marks 40 years of transformative impact, the journey continues. Guided by science and driven by innovation, biotechnology is powering India's future. Together, let us harness biotechnology and biomanufacturing as we advance toward Viksit Bharat by 2047.
That's an incredible journey, which reminds us of the core values that continue to guide us. May I now invite Dr. Rajesh S. Gokhale, Secretary DBT, to kindly address the audience, please.
Honorable Minister, Union Minister for Science and Technology, Dr. Jitendra Singh ji, Foundation Day Speaker, Dr. Govind Makharia, ASN FA of Department of Biotechnology, Mrs. Yatendra Prasad, Joint Secretary DBT, Mrs. Ekta Bishnoi, past and present members of Department of Biotechnology, all of you are here. Actually, it's exciting to see all of you here. Directors and scientists of DBT institutions, and ladies and gentlemen. I think this is first of all, let me congratulate all of you and give you the best wishes for the 40th DBT Foundation Day. I think we deserve a good round of applause for amazing things that what we have done over the 40 years of time. And I think every individual, every person is as important in the cog of the wheel as we have kind of either it's an administration, it's a finance or the scientific department or any person involved in this activity is the real version of, of what country requires to do actually. I think that's why I've been trying to say, I thought we should call DBT today. I like to give some acronyms once in a while. And I think the Department of Biotechnology can in fact be a department of bold transformation. And as our Joint Secretary talked about, the BIRAC model which was set up in 2012, every department now wants to replicate that today actually, which is after 10 to 15 years of time. And I think we should really feel proud about the activities of bold transformations that we are trying to do this in India. From a Bio-E3 policy perspective, you can look at, or from variety of aspects of life, what we have tried to mentor it. And that's what I'm calling from lab science to bioeconomy engine of the country. And you can see from 1986 onwards, we started building capacity, cutting edge research. In 2012, we set up BIRAC, but really the entrepreneurship took over at 2014 when this government announced the startup policy. Otherwise, things were just lagging behind. And then we're now focusing on bioeconomy of the country. And to do this, the whole challenge really is that how to transform the biology into an industrial force. And that's the major focus of our department as of today, such that it builds engineer the future of the healthcare, it promotes sustainable agriculture and manufacturing, as well as foster the circular bioeconomy for the country. And to do this, in last few years, under the leadership of Honorable Minister, I think we have taken a couple of transformative decisions. One was to integration of all the institutions as Biotechnology Research Innovation Council. This puts together as a pedestal as one of the key leading players of biotech ecosystem in the country. And as many of you would have remembered from a past presentation, in fact, if you really look at from the way of publications and other activities, Nature Index stands by BRIC as the top institution in the country in the biological sciences and the systems. At the same time, the Bio-E3 policy, which is biotechnology for economy, environment, and employment, is one of the first futuristic policy of how our growth potential in our various aspects of industrial biotechnology and various aspects of life processes would in fact change the game for the country. And I think as you would realize or would have seen, there are so much of activity going on in the department that the bold transformation activities are unprecedented and can really change the entire gamut of Viksit Bharat's innovation capacity to look at. What I thought I will do is I'll show you what we have been doing together, and I actually put it into 3 different pieces. And as many people think that DBT is just a funding agency actually. And they think that's sufficient for us to do and that's the only part. Whereas I personally believe that it's basically forges the collective intelligence and the networking capacity all across the country, which is so critical and important that you cannot miss it in the perspective to look at. And there are 3 arms to it actually. The first arm is a knowledge layer arm, which is basically create science and technology, develop innovation, and do infrastructure. And all of these, in fact, becomes the foundation stone for the next layer, which is the translational layer, where we have set up various financial models, looked at startups, ecosystem, as well as partnerships across international organizations and all, including, department has also tried out alternate investment funds and various other equity models, which are were not very popular at the time when we have tested all these activities. We have a variety of co-funding, India Alliance, programs with Wellcome Trust, and lots of activities that have been done that are very, very transformative for the country's progress. And eventually, what we like to look at is an outcome layer, which is of societal impact and sustainability, which are the two key pillars of what government wants from the Department of Biotechnology. And therefore I like to call it connecting science, scaling solutions, and transforming lives, actually. And I think that's the portfolio that one can define of Department of Biotechnology in this one precise slide. But I thought I should take an example today to give you a clear-cut picture of how science and technological developments, in fact, are crucial and very important from the point of view of how one can progress in the futuristic goals of the country's progress. And therefore, I would first put together all the platforms for innovation, production, and economic growth. I mean, biopharma and vaccines is obviously one of the key parameters that we can look at. I mean, in fact, you can almost say that the vaccine industry got started because of DBT's intervention with Shanta Biotech and eventually with Bharat Biotech industry taking up. And now during the COVID, it became even bigger industry with Mission COVID Suraksha program that actually implemented across a variety of platforms and technological growth, what is happening. In fact, now we have an opportunity to look at next generation biologics like cell and gene therapy. The first trial was done again from a Department of Biotechnology institution in STEM and CMC Vellore combined in CSCR. And eventually we need to look at now digital health integration of AI-driven drug discovery programs, which also we are embarking upon by various other activities that are important to look at. The second part is the bioagriculture. And I will talk a little bit more about this today because I've never spoken about bioagriculture component of our Department of Biotechnology's portfolio. And I thought maybe I should spend time and give you an example of how amazing things are happening because of science and technology intervention and the policies that Government of India has taken further ahead. The bioindustrial and green manufacturing is obviously one of the key perspectives for future growth. The bio-based feedstocks, as you heard Honorable Prime Minister saying that biomass and the biotechnological growth will actually be the future for the country. The bioenergy sectors, like for example, you look at biohydrogen, bioethanol, variety of sectors will tremendously provide growth to the country and the most sustainable resource of how valorization of biomass can in fact change the economic goal. The blue economy, which is again a very new area of perspective for looking at marine bioresource and algal biofuels and carbon capture. And finally, all the enabling platforms which are biomanufacturing hub, biofoundries and AI genomics and synthetic biology, and clearly leading to the digital twins that are actually of providing model systems of how we will progress further ahead. So let me talk about the genome editing of future-ready smart crops actually. And I think this is an example that has happened within the last 4 years of time. And therefore you can see how transformative activities can really change the gamut of the game. In 31st March 2022, actually government adopted a facilitative science-based approach to genome editing. And it's announced that all the crops that does not contain the foreign DNA can in fact be regulated, will not be regulated as genetically modified organisms. And one transformative step allowed Department of Biotechnology to come up with improved crops and varieties, accelerating their release and commercial use. And in fact, DBT within 6 months identified and announced the guidelines for safety assessment as well as identified the standard operating procedures actually. Many of you think, why would this be important? But before this, if you really look at the era of breeding and variety development, the conventional breeding technologies would take 10 to 12 years. And this is a linear model. I don't want to go into every step of it, but there are at least 11 steps before the seed is provided by a breeder seed or a foundation seed gets provided to the farmer. So once the variety is identified, you do crosses, you identify parents, you hybridize, and all of these time takes, and by the time new disease crops up. So by the time you create one disease-resistant variety by transforming this, you have a new disease actually starting to emerge. And therefore, this was a kind of a little bit of a challenge for our farmers because you're always running behind the schedule actually. However, what Department of Biotechnology also did was actually provided speed breeding and genomic selection, which including double haploids, which actually decreased the time from 6 to 7 to 8 years, you can imagine, where genome-assisted breeding projects were taken up, or even speed breeding centers like these were set up. First of this was in the Varanasi, which was inaugurated by Honorable Prime Minister again. The second was in Ludhiana, and the third one is in Mohali. And all of these centers really provide and accelerate the development of new crop varieties that are growing multiple generations in a single year. So you can see, while as I gave you an idea, that while we keep producing technology, we keep producing innovations, we also fortify other aspects of life which are required to be able to complete the cycle. And now you can imagine what is the gene editing technology will give you actually. And this gene editing technology, or either base editing, whatever you call it actually, it can now reduce the timeline to 3 to 5 years for the crop to come. Because there is no repeated back crossing is really required to do. You have no linkage drag. You don't carry over any further genes along with it actually to transform. The trait-specific editing happens, as well as there is rapid fixation, and then smaller field trials because genotype is already adapted actually. The genotype is not really known because it's already available, with genotypes are there. You can only do that trait in that and then create these activities. And I think from strategic implications, it's extremely important for our country because climate resilient varieties in one breeding cycle you can generate. And this will do away with the challenges of farmers having to wait for new varieties to come, and faster response to emerging pests and diseases, and also enables precision breeding for elite cultivars for the future of our country. And you can see this is a classical example of how rapidly this is the first technology from Department of Biotechnology that has come to the here, where mustard has been gene edited to actually give a canola quality of mustard actually. And this field trial is already going on. In less than 3 years' time, actually, it has reached this purpose. And what has been done in this is we have mutated 10 transporters that transport the glucosinolate molecule from the seeds. Because the oil seeds get rancid, and therefore you don't need very large quantity of this glucosinolate in it actually. Whereas glucosinolate is required in the leaf because it's also acts as an antifungal and antibacterial growth actually. So typically you cannot knock it out from the plant. And therefore what has been selectively done is the transporters that transport to the seeds have been only mutated, and thereby you can see the ppm is 17 ppm now, and in fact the glucosinolate content in canola oil is in fact 30 ppm. So it's even better than the canola oil, quality oil, which is widely distributed in India. And these are the kind of amazing things that can happen in a very short period of time. Of course, you can convert another technology by converting sulforaphane in these molecules as well, which is the molecule that is available as an antioxidant in broccoli. So there are a variety of activities you can do, but this is just to give you a list of ongoing programs that Department of Biotechnology funded, and next couple of years you will start to see these amazing benefits coming out of it. You can see the pigeon pea, herbicide tolerance, tomato, biotic stress, fruit quality, nutrient efficiency. For rice, there are a large number of products. You want to have an architecture where you can use mechanized farming so that the plant is growing in a different ways. Low lignin and efficient feedstock, wheat for example, plant architecture, and each one of them has in fact been funded by Department of, already funded to various institutions. And you can see the consortium of large number of institutions came together to take these technologies, to develop these technologies. For example, soya bean, chicken pea, sugarcane, onion, eucalyptus, coffee, banana, groundnut, mustard, maize, potato. You can talk about it, the agriculture crop and the variety that is done. And you can see the impact now, where it used to take 10 to 12 years for farmers to get the varieties. Now you can get the varieties in a very, very short period of time. So how a policy by Government of India, which was worked by their Ministry of Environmental Science, the Ministry of Environment and MOEFCC, as well as DBT together, and worked out in a way that has actually transformed our agriculture ecosystem forever. And similar kind of policies are there available for Bio-E3 policy, actually what Honorable Prime Minister and was approved, as well as our minister actually announced this on August 31st. And I think again you can imagine that it is a multi-objective outcome engine. We are not talking about a project or a proposal here. What we are talking about are multi-objectives which have a very complex parameterization to be done. And therefore the Department of Biotechnology will have to move away from classical challenging problems of looking at, because you have to do multiple scales in a simultaneous purpose actually. And these are all non-linear, interconnected and scale dependent issues. So for example, climate resilience, nutritional security, affordable healthcare, circular bioeconomy, rural and urban livelihoods. If one wants to play this game, then we need to do away with what I call strategic project management. And what happens if you optimize one component of it? For example, if you optimize on high yield crops, the groundwater and soil depletion occurs. If you optimize on potent drugs, the unaffordable therapies come. If you do industrial efficiency, the carbon intensity increases. If you do food production, the nutritional imbalance occurs. So you cannot optimize a single component. And therefore, what department will adopt to is what I call paradigm shift from component optimization to system level redesign actually. So can we do now biotech driven circular bioeconomy models can for the tier 2, tier 3 cities that can completely change the innovation ecosystem forever. Now I want to give you 3 examples of this, that this is not new actually. However, technological innovations have happened in different ways in our country, and this is an example to tell you, for example, successive biological revolutions have shaped India's development. And one of the key one was after 1965 crisis which happened in our country, food crisis, back to back 3 monsoons failed. And you can see the green revolutions happened after that. Now this was happened by harnessing the power of living systems actually. So basically you have high yielding varieties were developed, expansion of irrigation structure, mechanization of agriculture, chemical fertilizers and pesticides, IARI education system got set up, and seed technology and distribution got set up. So again, biology, using biological process to continue country's progress, again is not a new thing. The second example is of milk production. India had an acute milk shortages, and however, one needs to do a system level engineering processes. And in this case, the system level engineering was setting up of an aggregator cooperative model. And this cooperative model really worked because the daily production assured procurement and steady cash flow for farmers was there. And because the milk was perishable, the homogeneous, the collection became a very, very easy aspect of taking these activities. And this became one chilling center, and 1,000 of small shareholders could collect this and put them together. So you can see how system level thinking and thinking about how complex challenges gets resolved is a wonderful example. But again, now if you go back and understand, would this complex aggregator model worked in agriculture sector? And you can see it has not worked very well. In fact, this has been unsuccessful in grains, storable farmers for sell individually, prices fluctuate, or fruits and vegetables, aggregation less compelling outside milk. And therefore, you need to think of a challenges of why something works, why something does not work, and how science and technology together along with system level thinking allows you to carry out this activity. The final example is of biomanufacturing, COVID-19 pandemic, again, a watershed movement in the country's history, where Department of Biotechnology again played a stellar role of developing various technologies all across through the company sectors. And you can imagine any technology that is really required in this world is available in the globalized technology advanced society that is present in India. And the entire world is looking at India of how vaccinations and how biomanufacturing capacity of 2 billion dosage could be manufactured in such a short period of time and given to people. And I think these are amazing stories, and just tells us that if we focus on bioindustrial and bioengineering of health, we can do really amazing things for future of our country. How should we really do it? And system level redesign means actually looking at 3 perspectives actually. One is the biological layer, which is what we used to do. The second is a digital layer, and again, AI and other technologies are emerging very, very rapidly, as you would have realized last week of AI hubs of people coming here. They're all looking for applications. And the applications are going to come in biological systems only actually. They can develop technology, but the technology is only as useful as users are. And the users are going to come from biological systems. And finally, it has to bring value to the socio-economic layer actually. And I think these 3 together, if we start thinking about it from a departmental point of view, we can really change the system. And I'll show you how a possible BioE3 rural biomanufacturing cluster can be created actually. And you can imagine a bioconversion platforms can be created, the biological resources convert waste to value, and biomanufacturing infrastructure can be put in place. At the same time, the supply chains needs to be set up, the markets and policy and circular economy. And believe me, this will change the tier 2, tier 3 cities in our country actually forever. Because the agrarian industry processes are there, You produce there, you use there, you generate energy, you generate fertilizer, you generate food, and you do everything within own systems. And these autonomous systems can be a very, very powerful tool to how future of our country will look at actually. And I've listed down these details, but these can be talked about later as DBT would look into this. Eventually, we also need to look at industrial biotechnology as coming up with streamlining biosafety regulations for industrial biotechnology under contained conditions, where genetically engineered organisms under strictly contained conditions can result in chemically defined end product, do not contain any viable living gems. And therefore, one can create these kind of new regulations as well that can again be transformative for country. I'll end by saying that the future will not build by the better parts alone, but by the better design systems that deliver planetary, human, and economic outcomes simultaneously. And I think that's where the Department of Biotechnology as a Department of Bold Transformation will play a role. And BioE3 really integrates the biology, the digital intelligence, and the socio-economic clusters into a way that optimizes economy, environment, and employment. And that's why the whole policy name is BioE3, which actually allows you to carry out these activities. I'll just leave you with this last slide. Till now, human has been carrying out all these activities by its cognitive capabilities, which is an adaptive capability and the natural intelligence of humans that has been used. However, two very powerful tools, biological intelligence, which is the DNA encoded one, and the artificial intelligence, which is the algorithmic or amplify human understanding, in fact, can make this triad of intelligence a very, very powerful mechanism, which is a natural intelligence, biological intelligence, and artificial intelligence. And that's where the DNA of humans, of plants, of insects, of animals, of cells have a tremendous amount of role to play. And that is where I keep saying that the biotechnology will completely revolutionize the transformative paradigm of accelerated co-evolutionary processes. And these processes will become so fast that in the next 25 years, the bioeconomy will become the major stay of our country's progress. I think I thank you, all of you, for taking time, and I need to thank Dr. Satakshi Chatterjee and Shri Ranganathan, who puts my ideas into the slides and does fantastic job. Thank you, all of you, for time.
Thank you, sir, for your enlightening remarks and clear vision about biotechnology, which is a sunrise sector and a powerhouse that will fuel innovation and sustainable economic growth of the country. DBT has revamped its website to align with the Government of India's Digital Footprint Initiative, reflecting its commitment to a unified and standardized digital presence across all ministerial platforms. Let's now watch the video on DBT's Digital Brand Identity Manual compliant website developed by NIC.
Establishes a unified digital identity across government websites, apps, and social media, enabling consistent design and functionality that enhance trust, recognition, and seamless citizen experience. DBIM standardized visual design system defines typography, color palettes, and iconography to ensure visual harmony using Noto Sans for multilingual accessibility, WCAG compliant colors for inclusivity, and structured icons for intuitive navigation. This effort reflects a strong in-house development approach led technically by NIC posted at DBT. To date, very few ministry and department websites have been launched under the DBIM framework, reinforcing the government's commitment to digital transformation and uniform web standards.
May I now solicit Dr. Jitendra Singh Ji, Honorable Union Minister of State, to formally launch the website. May I also solicit the presence of Shri Naveen Kumar, Deputy DG NIC, Shri Rajiv Goyal, Senior Director IT NIC, Shri Pradeep Vats, Senior Technical Assistant NIC, Thank you, everyone. We now request Mr. G.S. Krishnan, President of the Association of Biotechnology Lead Enterprises, Bengaluru, who has joined us online to present a brief on the Sujivika Bioproduct web portal developed by ABLE.
Very good afternoon, Honorable Minister Dr. Jitendra Singh Ji, Secretary DBT Dr. Rajesh Gokhale, other distinguished gathering. It's indeed a great pride to be part of this launch. My sincere apologies, I could not join in person. Thanks to DBT for entrusting the responsibility to come out with this portal. In fact, it all started last year when I had a meeting with Dr. Rajesh Gokhale, where he was very keen on looking at how do we utilize the import statistics of various biotech products into India, which could probably be an eye-opener for some of the startups and entrepreneurs. And we had come out with this after 6 months and ably supported by the DBT team. My heartiest congratulations to DBT on the occasion of Foundation Day, and I'm sure this particular web portal will be a bold transformation rather, in line with what Dr. Rajesh Gokhale is thinking. About the portal, Sujivika, a trade statistic digital portal, site for unified Vigyan, related imports, knowledge base, and analytics. It is being developed to present official import data of products which are used in biotech segment. These statistics, which are obtained using the DGFT import data, is collated in a structured and accessible manner for the convenience and use of the biotech fraternity. The advantages of the portal: it has sector-wise import statistics using official DGFT import data and industry sources across key biotechnology domains. Most of the products imported are used as critical processing aids in different biotech segments, and in a few cases, concentrates to be formulated or finished product traded locally. This provides information why biotech import intelligence is critical to understand and identify products for local innovation, indigenization, and manufacture. The structured trade data supports policy planning, research prioritization, and industry collaboration to step up on biomanufacturing locally. Next slide, please. This gives at a glance the overview of the import data. Very clearly, value of US dollar 10.1 billion is being imported in the order of biopharmaceutical segment, bioindustrial, and bioagriculture. So this will give an idea about the volume and the value which we are importing and how we could look at exploring the local opportunities. When you get into the details of each of this segment, of course, this is, next slide, please. Yeah, This overview of import data is for the year 2024 and 2025. You can see that it's almost the same, except in the year 2025, there are slightly higher imports. Next slide, please. This slide will give an overview. When you go into the detail of biopharma, you can see that the main imports are coming from antibiotics, or for that matter, biochemicals, anti-diabetic drug, which India has a very big opportunity, and other biological ingredients, which is just to give an idea about, at a glance, what are we talking about from an import point of view. Next slide, please. Bioindustrial. This is again very clearly not only the chemicals, biochemicals which we are importing, methanol, the volume we have been importing, enzymes which play an important role, which are catalysts for speeding up a chemical process, today predominantly is being imported. And we also have some of the, what we call the high value, low volume enzymes, which is a very big opportunity, which are biocatalysts for the pharmaceutical segments. Likewise, the other specific areas of food ingredients, flavors and fragrances, other essential oils being imported. Next slide, please. The bioagriculture segment again is a very critical area to understand the biopesticides being imported, agrochemicals, biostimulants, and biofertilizers. These are to just give you at a glance about various imports being brought into the country, specifically for the biotech segment. We believe this will be a very valuable tool for entrepreneurs and startups to look at near to market opportunities and take advantage of the Bio E3 policy. I would like to thank Dr. Omkar and the DBT team, and Dr. Debashish Dash and ILS team, and also our ABLE team in Bangalore, and Mr. Prashant from Nobly for technical support. With this, I would like to thank you again for the opportunity, and namaskar to the minister and rest of you over there. Thank you very much.
Thank you, Mr. Krishnan. May I now request Dr. Jitendra Singh Ji, Honorable Union Minister of State, to formally launch the Sujivika web portal. I also request Dr. Omkar Nath Tiwari, Scientist FDBT, and Dr. Debashish Das, Director, BRIC, Institute of Life Sciences, to join us on the stage. Thank you, sir. Now I humbly request Dr. Jitendra Singh Ji, Honorable Union Minister of State, Government of India, to address the gathering and enlighten us with his words of wisdom. Ladies and gentlemen, please welcome him with a massive round of applause.
Thank you very much. Good afternoon, everybody. I know for sure this is already an enlightened audience, so I don't have to bring in any much more of light, but nevertheless, I have to perform the pleasant task of greeting you all on the Foundation Day. Secretary Dr. Rajesh Gokhale, Ekta Bishnoi, Mrs. Prasad, and Dr. Makharia, members of the faculty, different directors I can see over here, ladies and gentlemen, and of course the BIREC MD also there. I think much has already been said. So as far as the Foundation Day is concerned, it's been a long journey, completing 4 decades. And Rajesh was keen to observe the 40 years because human beings are always in haste to celebrate whatever comes their way. But many of us not sure about the 50 years. So I think that's the underlying instinct. But nevertheless, it's been quite an eventful journey. And I myself personally also been associated with this department for almost as long as 30 years. I think when Dr. Manju Sharma was there, I in fact even spent about 2 weeks just trying to understand what it was all about, because it was in fact a new addition to India's science academics at that time, having an exclusive Department of Biotechnology. And since much is related to the health sciences. But I have no hesitation to say that the department has received its visibility only in the last 1 decade. So those of us who had some stake either in research or otherwise would be aware of where it was. Otherwise, till today even, it doesn't have an address of its own. It is care of ITBP. No, not that it is heavily guarded, but for some reason. But I'm sure now with the new buildings having come up, Rajesh will have an address on his own also. But the credit goes to Prime Minister Modi because he picked up those sectors which had remained hitherto unexplored or underexplored. And when he was briefed and he realized that biotechnology is one such sector which had a lot of potential but had not been exploited to the maximum extent and which was also futuristic, it was he who came forward, and I must say that but for his support it would not have been possible for us to pass this Bio E3 policy in the cabinet. Rajesh would bear me out that there were a series of presentations done directly before Honorable Prime Minister personally. So each time he would ask us to come up with some more of descriptions which were done. And finally, when it was made clear that maybe today the common man does not realize the relevance of it, but tomorrow at least we would be able to claim that we were not the late initiators as we were in case of IT. And this is precisely what the Honorable Prime Minister also explained to his colleagues in the cabinet meeting. And I'm also glad, as you saw, the Independence Day address from the ramparts of Red Fort, he is calling upon youth to make use of this policy. Now, this rarely happens. Those who have watched the journey of independent India, particularly from the media, and have covered the Independence Day addresses, would recall and would bear me out. Hardly ever such a subject occupies the theme of an Independence Day address of Prime Minister, because that is an indication of high prioritization of the government in place, and in fact a declaration of intent of the government in place which goes across the globe. And that is also in keeping with what was being said in the video, that this is possibly the next industrial revolution that the globe is going to witness. And that is a considered view held even by the economists across the world. So when I was saying about the last 1 decade's journey, since we are talking in the terms of statistics in this audience of scientific researchers bearing out statistical-based evidence, I think the number of startups that we had in 2014 when this government came was not even 3-digit. So it was rather embarrassing to say how many startups we have in biotech sector. It was hardly 50, 60, 70. Today it is more than 11,000. So in 40 years of the journey of the Department of Biotechnology, in 30 years we could gather 50, and in the last 10 years as many as 11,000. And you can imagine the number of jobs being generated in this sector must be many, many more times. And therefore also the bioeconomy. We stood at just $10 billion in 2014. We are now close to $166 billion, and our projection is that we will be 300 billion by 2030 or so. Biomanufacturing, as I think Ekta was mentioning, we are already Pacific 3, Indo-Pacific 3, and rank 12 or 13 the world over. And therefore, tomorrow when we are one among the very few in the world who have a dedicated biotechnology policy, this Bio E3, biotechnology for environment, for economy, for employment. So tomorrow when the world rises up to the virtues of biotechnology, we would have the claim to say, look here, we are among the spearheaders, or the torchbearers, just as the recently concluded AI summit has enabled us to make that claim in the realms of AI. And so also our BIRAC experiment, Rajesh is right, it's become so popular, it's become like a role model for the others to follow. And in fact, we also have to an extent tried to exchange the best practices with the other model called in-space that we have in space. So incidentally, since I'm related to all these ministries, so I had the opportunity to learn and unlearn what to learn from where and what to unlearn from where. So in-space was a very beautiful experiment where we started with just one figure, one-digit startup. Today we have more than 400. And our economy was dismal, and today we have more than $8 billion US, and we hope to go up to 40, 45 billion just in 8 years. That was because of in-space. So a structured mechanism, which is rarely available. Otherwise, the collaborations happen randomly. I know someone in the scientific circle through my networking, through my conferences. At conferences, most of us are occasions for us to find like-minded collaborators. And that's how we randomly do. We don't have an institutionalized mechanism. So in-space was like that experiment. BIRAC is the other one. And it's become quite popular among the youngsters. And it determines the nature of collaboration, the scale of collaboration, even the entities of collaboration. And also recently we have launched the National Biofoundry Network. We are, I think, the first department in Government of India, at least from the science domain, who have engaged in an MOU with ISRO. So when I suggested that, everybody looked at in astonishment. I said, look here, being a part of the medical profession, I can recall 20 years back, the sports medicine was very much looked down upon. And in the medical parlance, sports doctor means वैसे ही है. A failed medico was a sport. Now it's such a lucrative process. For each of the tournament, they are paid much, much more than a general physician. And so also we are going to witness a day when we would have space physicians, in fact. Like most of the experiments which were done by Shubhashu Shukla, half of them were related to life sciences, health and biotechnology. They were related to biogenesis, the muscle wasting and recouping. They were related to the cognitive effects of electronic gaze and central electronic watching. Ideally, a physician could have been doing that. But since we didn't have a physician to fly, soon we will have a bunch of astronauts also trained as physicians. The more number of such flights happening from across the globe. And again, we will be among the first to have an institutionalized understanding between the Department of Space and the Department of Biotechnology. Again, many of the other countries don't have that. Therefore, also the Genome India Limited is another initiative where we've already screened, sequenced 10,000 individuals. Our initial target is 1 million. Many of the private sector groups are also into this. And I think for the first time we have made the best use of some of our institutes which are dedicated to this work. We have 95 bioincubators across 21 states and UTs. We have 4 regional centers for mentoring, and we have 7 technology transfer centers. And very recently, BIRAC also launched the first call of its 1 lakh crore RDI fund. And the first call was for 2,000 crore, and subsequently we move on. I think the next call also will be by April or May. So those who are looking forward to it, the message could go across because there's a lot of enthusiasm. Now, though it doesn't sound very polite to say, because the mindset doesn't change easily. So many are actually looking up to BIRAC as another citizen cooperative bank, which is not so. And they are also looking at RDI as another fund khol diya sarkar ne. So RDI is meant for a certain level of entrepreneurs, like we technically say T4. So if you have qualified maybe as startups or other startups and you reached a certain level where you are on the verge of taking off in a big way as an entrepreneur, then we try to accelerate you through this fund. That doesn't mean many of the boys and girls come to me and ask me, what about us if you have not graduated to the level? So there is something more for them also. So this is a huge ecosystem. This RDI fund is part of that. And BIRAC itself is also rendering support to the early starters, to the startups. They have different kinds of fund. Then you have the startup policy as well. And very recently, when Prime Minister shifted over to the Seva Tirath building, the first 3 or 4 decisions he took on the first day in the office, one was the 10,000 crore fund of funds for deep tech startups. So you can understand, this is a government which is according a very high priority. So we should look at it as a larger as a component of a larger ecosystem. And the impact of this, as he rightly mentioned, the agriculture, crop resilience, bioenergy, environment technology, biotech education is such diverse. And with the addition of artificial intelligence, many people tend to believe, I was trying to explain the last day also, that artificial intelligence is something like another component. Now biotechnology, now this is some deep tech. It's not so. It's just like a tool. In simple words, I was trying to explain them कि पुराने ज़माने में कलम से लिखते थे, फिर फाउंटेन पेन आया, फिर बॉल पेन आया, फिर रेमिंगटन का टाइपराइटर आया, फिर कंप्यूटर आया, फिर आप कंप्यूटर से बैठे वो देखिए मीडिया वाले लिख रहे हैं, real time. So this is an evolution. So also AI is a tool. But biotechnology will be one of the biggest beneficiaries. So just as writing column took half a day, you see the old scriptures. The writing fountain pen was stronger, then the ball pen, then the Remington, and then so on. So AI is not to be seen as it's a kind of a enabling tool for us, and most of our work in biotechnology is going to be facilitated with this gene sequencing. Otherwise, will take a very long time. Even in our life sciences, Dr. Makharia is also there. If you do these cultures, it takes years, days, months. Here you can do it in seconds. More specific, more sensitive, and less time consuming, and also cost effective. So if AI is going to benefit a sector to the maximum extent, that is going to be biotechnology, and therefore I have always been insisting on a larger synergy among the science departments and also extra science departments. Within the same ministry, we have CSIR also doing same kind of a work. Now, Dr. Makharia is going to talk to you about celiac disease after this, because that's been funded by DBT. But had he been in CSIR, he would have been talking about sickle cell disease, because CSIR has funded sickle cell. So the same ministry is into biotechnology. They are also doing. They have also come out with some kind of genetic options for sickle cell disease. Similarly, the hemophilia, the factor 8. I was telling the other day, because I don't usually try not to repeat what has already been said, as I said, it's already an enlightened audience. I said we should go out and tell the people, when we talk of Vishwabandhu, what could be better example of Vishwabandhu than Subhashu's experiments, which were, the kits were created by the Department of Biotechnology. The benefit is going to be for the entire mankind. And then when we talk of hemophilia, we came out with the first successful genetic trial, again funded through Department of Biotechnology, through BIREC. And the best part of it is that so far we are creating solutions which are for the benefit of the rest of the world. We are now also in a position to create solutions which were not inherently born out of us. Hemophilia was first reported in the royal family of UK, and the older generation of physicians would recall, because now I am also growing ancient. When the textbooks of Britain were read, that was Price textbook, which was read up to 1960, Dr. Makharia would know. Then, of course, the entire thing shifted over to Americans, and then the Harrison book replaced the Price book. And they used to use, all these fancy terms. So for a long time, it was known as Queen's disease, because the first case was reported from a cousin of Queen Victoria. Today, it is we in India who are giving a solution to it, to remedy. So we are not only becoming Atmanirbhar, we are also in a position of offering others to be Nirbhar on us. So that is the paradigm shift that is sought to be projected through our technological capacities. And finally, of course, Rajesh has said that NI plus AI plus BI, biotechnology intelligence, of course, that's precisely what is happening. But if I don't know which will take the better of the other. Like that famous anecdote of Bernard Shaw being approached by a celebrity who wanted to marry him and try to woo him, saying that the offspring that we have will have my beauty and your brains. And he said, what happens if it goes the other way around? So I think that is why Rajesh has also added AI. So AI will take care that the reverse transport doesn't happen. But nevertheless, these are going to be very fascinating times in the next few decades. And finally, I have to congratulate, I think finally, at the end of the day, the media person say, Foundation Day, okay, goody, okay. Now what is the news? because the editor would say that the Foundation Day to roz hi hota hai kahin na kahin. So the news is this, I have to compliment the able Dr. Krishnan also, this Sujivika, which is the biotech product data portal. So in simple words, it's an AI-driven portal dealing with biotech products. Of course, the import products and technologies, and it also has a repository of the domestic products. But the import, since was more vital and not easily accessible, so it's a very convenient and very easily accessible biotech or AI-driven biotech product portal. The name is Sujivika. So Rajesh has learned the tone and tenor of this government and chosen a name which means easy Jivika, Saral Jivika, Sukhi Jivika rather. And broadly speaking, it will be dedicated to three broad purposes. A is precise decision making, and that too evidence-based. So it will enable us quickly through AI mode to decide which import product or which import technology is most suitable or most compatible for the kind of work that I am doing. Also for academic and technical research to identify the high impact import substitutions. And finally, to promote the PPP models, because this government is open to public-private participation. So it might also help us to decide whom to collaborate with. So it will be scientifically designed collaborations, AI-driven, not randomly done, not made in heaven, like many other things. It will be made on the ground. So congratulations for this new launch, because I insisted this morning to Rajesh, I said, if you celebrate Foundation Day, okay, but if you have to make a news, you have to launch something. And I'm glad that he's been able to do this. So thank you very much and congratulations, Rajesh.
Thank you, sir, for your path-guiding words. And I now invite Dr. Kakoli De Dasgupta, Scientist of DBT, for proposing the vote of thanks.
Good evening. So today it's my immense privilege and pleasure to be here as we celebrate the 40th Foundation Day of Department of Biotechnology. On this occasion, on behalf of Department of Biotech, I offer my sincere gratitude to Shri Dr. Jitendra Singh Ji, our Honorable Union Minister of State, Independent Charge for S&T and Earth Sciences, Minister of State, PMO, Minister of State, Ministry of Personnel, Public Grievances, Pension, Department of Atomic Energy, and Department of Space. Sir, thank you for having spared your valuable time to be with us amidst your recurrent meetings and tours across the country. And sir, your constant guidance and unwavering support in steering us through diverse paths through this multidisciplinary field of biotech is truly incredible. And we'll continue to look forward to your perpetual guidance and steadfast support in our future endeavors as well, and your address with really incredible humor as well. Thank you so much, sir. I also take this opportunity to express my sincere thanks to Secretary DBT and Chairman and DG BRIC for being a rock of support to us and your sustained guidance and inspiring us to drive and boost towards knowledge and innovation-driven bioeconomy for our country. My sincere thanks to Professor Govind Makharia, sir, Professor Gastroenterology, AIMS, for his special address, and thank you, sir, for your insightful address. I would express my sincere thanks to our Joint Secretary, Srimati Ekta Vishnoi, for her concise yet elaborated address on the DBT's aim, scope, and activities. My heartfelt thanks to Srimati Yatinder Prasad, Additional Secretary and Financial Advisor DBT, for her all-round support in DBT's all activities. Finally, I thank all the directors of our autonomous institutions, senior former colleagues from DBT, my current colleagues, invitees from media, all esteemed guests, ladies and gentlemen, for attending this event. Thank you all. चौहान और मनोज मधवाल का भी लिखा था, बट मुझे लगा कि वो बोल रहे हैं कि नहीं होगा, नहीं होगा। सही बात।
I request everyone to please settle down. We still have the second session. Please take your seats. I request the audience seated.
Stay seated for the second session.
Please stay seated for the second session.